All right, let's dive right in. Today, we are going to crack the code on what it takes to ace your AI agent developer interview. We're going way beyond the basic tutorials to give you the mental framework you absolutely need to impress. We're talking about moving from theory to the kind of production level thinking that actually gets you hired.
Look, you've got the skills. You know your way around Python. You can probably train a model in your sleep. But building AI agents, that is a whole different ballgame. It's all about systems thinking. In that interview, they're not just going to ask you what you can build. They're going to grill you on how you think about the way these systems reason, act, and, most importantly, how they break.
You've seen it a million times in tutorials, right? That one magic line of code, agent.run. And it feels great until it just doesn't work. Then you're stuck trying to figure out what went wrong inside a total black box. Well, today we are popping the hood. We're going to take that black box apart piece by piece. And to make sure this all really clicks, our expert Rajan is standing by to give us a hands-on demo at the end. Okay, so here's our game plan. Think of this as your personal study guide for the interview. First, we'll cover the engine of every agent, the core execution loop. Then, we'll give our agent hands and a brain. That's tools and memory. After that, we'll talk about how to actually build this stuff in the real world with frameworks. And we'll wrap up with the one thing that really separates the pros from the rookies, the production mindset.
First things first, the absolute foundation of everything, the core execution loop. And I want to be really clear about this. This isn't just one way to build an agent. This is the fundamental pattern behind pretty much every agent system out there, from the simplest little chatbot to the most complex workflow you can imagine.
If you only take one thing away from our time together today, please let it be this. This is the big mindset shift. An AI agent is not some magical monolithic thing. It's a loop. It's a predictable, repeatable cycle that has state, tools, and memory. Really getting this idea is the key to building and, believe me, debugging them. And here is that loop broken down. You can think of it like a 6-step dance. First, the agent observes. It gathers up all the context. Then it thinks. This is where the LLM does its reasoning. Based on that, it decides on one specific action. Then it acts on that decision, which usually means calling a tool. Now this is crucial. It then updates its state with the result of that action. And finally, it asks, am I done? If not, boom, right back to the top of the loop.
So why is this so critical for your interview? Because when your agent messes up, and trust me, it will, this loop is your treasure map for debugging. Did it fail at the observe step because it didn't have the right info? Or maybe the act step failed because an API call timed out. Knowing this loop lets you go, aha, the problem is right here. That's the kind of answer that gets you hired. Okay, so we've got our engine, the loop. But how does it actually do anything? Well, that's where tools come in. If the execution loop is the agent's engine, then tools are its hands. They're what let it reach out beyond its training data and interact with the real world. And the difference is just night and day. Without tools, you basically have a really smart chatbot. It knows a lot, but it's stuck in the past. But once you give it tools, it's not a chatbot anymore. It's a teammate. It can search the web for you. It can query your company's private database. It can run calculations. It's the difference between a talker and a doer. Now, a real production-grade tool isn't just a simple Python function. It's actually got 3 parts. Yeah, you've got the function implementation, the code that does the work, but just as important, you have the schema definition. This is basically the instruction manual you give to the LLM. It tells it what the tool does, how to use it, and when it should use it. Getting this right is everything. And finally, you wrap it all in a class for things like error handling. Okay, our agent has an engine and it has hands. So what's missing? A brain. It needs memory. Memory is what turns an agent from a simple tool that just executes one command at a time into a true assistant that actually understands the context of a conversation. You know, in production systems, memory isn't just one simple thing. We usually break it down into 3 types. You've got short-term memory, which is pretty straightforward. It just remembers what's happening in the current conversation. Then you have long-term memory, which stores facts that last across different sessions, like your name or your preferences. And then there's the really cool one, episodic memory. This lets the agent learn from its past successes and failures. Okay, this is definitely one of those moments where you might want to grab a quick screenshot. This is a super practical guide for your interview prep. Do you need to remember what you just talked about 5 minutes ago? That's short term. Do you need to remember a user's favorite setting from last week? That's long term. Do you need to figure out the best approach to a new problem based on a similar one from the past? That's episodic. All right, we have all the core concepts down. We've got the loop, tools, and memory.
So, how do we actually build this stuff on the job? Let's connect the dots from theory to the frameworks that interviewers are going to expect you to know, like LangChain and LangGraph. So, what's the difference between the two? Well, here's the best way to think about it. LangChain gives you the building blocks. It's like the box of Legos. You get all the pieces for models, tools, and memory. LangGraph, on the other hand, is the instruction manual. It provides the control flow, the blueprint that lets you orchestrate all those pieces into a reliable system. And this gets to a really critical point, the move from an implicit loop to an explicit graph. A simple while loop is easy to get started with, but the logic is kind of hidden inside the LLM's head, which can make it super unpredictable. LangGraph changes the game by turning your agent into a state machine, a graph with clear nodes and edges. This makes its behavior deterministic, which means it's testable and way, way more reliable for production. So, this last section is, in my opinion, what separates a good candidate from a great one. It's all about showing that you think beyond the perfect happy path prototype and you actually consider the messy realities of a production environment. A senior engineer isn't just impressed by what you can build. They want to know how you think about things when they break, so you can totally expect a question like this. They want to see that you've thought about all the weird edge cases and failures that are guaranteed to pop up in the real world. And here are some of the big ones you should be ready to talk about. You've got the dreaded infinite loop, where the agent just does the same thing over and over. Context windows can overflow, the LLM can hallucinate tools that don't even exist, external tools and APIs will fail, and over a long conversation, the agent can just forget what it was trying to do in the first place. Knowing these shows you've been around the block. And if you need a reason why this stuff matters, just look at this number. A prototype agent might fail 30% of the time in the real world. 30%. In production, that's not a bug, that's a complete disaster. This is exactly why that production mindset, with rock-solid error handling and logging, is just not optional. But here's the really empowering part. With everything we've talked about, the loop, the tools, the memory, you now have a complete mental model for this stuff. So when something breaks, you're not just guessing. You can systematically trace the problem right back to one of these core components and figure it out. So let's wrap it all up. Here's your final cheat sheet for that interview. The loop is the engine. Tools are the hands. Memory is the brain. Graphs give you the reliable blueprint. And the number one goal in any professional setting is always robustness. You now have the complete conceptual framework to understand, build, and debug AI agents. But theory is one thing. Seeing someone actually build it live is a whole other level. And for that, we're going to hand things over to our expert. Rajan, it is showtime now. The floor is all yours. You may now proceed with the demo.
Hi guys, okay, so it's demo time now. So we have a demo. Actually, this is a course on AI agents, how to build in Python. This is by LangChain Academy, and so I have downloaded this repo from the GitHub, and I am opening it in the Google Antigravity, which is similar to VS Code, but they have a lot of things added, like agent manager and the copilot area here that feels like more advanced. So you might want to try this as well. And so to start with this thing, we go through the concepts like how to use foundational models, like voice prompting, tools, web search, memory, and multi-modal messages, and then build a personal chat. So at least this thing will give you the idea of what questions they can ask in the interview. And then during the later part in the video, when we practice the interview questions and answers, you will be able to understand and prepare for the interview for the AI agents developer. So, and then there are other modules they're talking about MCP. I'll give you some idea on the MCP, and then they have built the multi-agent workflows here. This you can practice on your own later. I will execute some code. I will not execute all the code because I might be running into the rate limit thing. So to start with, they are using a UV package manager as per their instructions to build the environment, and like you can see here that we are in the virtual environment right now here, and so let me select the kernel. So I have executed this thing before. So this line here, like here it says load secrets from .env file. So I have downloaded the keys for the uh, model, for the like from Gemini, and there are other models you can use like ChatGPT. They have described many. Download their original repository. I have modified it to make it work for me and whichever model I am using. So this line here, it says load.environment. So this one is bringing the keys and from the .env. This is .env. I don't want to open it because it has the keys. So once we execute this one, we can use the model providers. I'm using Gemini 2.5 flashlight, and to use that they have provided this the LangChain is known for like building the useful wrappers around the Python libraries if you are new to that. So this is how they do it, like from the LangChain Google Chain AI you import this module, then you can say chat Google generative AI with the model name, temperature, max output tokens, and then you can say model.invoke, and then you can ask your questions. So this is same experience as like when you are working in the ChatGPT or any other LLM. We'll be talking like this. So this we are starting with the basics, so then it will give you some answers. It's a fun question. Who doesn't like capital and all that thing. Then initializing and invoking the model and agent. So now once you have the model object, using that model object you can pass that object here, model is a create agent, and then it will give you an agent. Now we have an agent object here. From there we can invoke the agent with the message, and then we pass the message like this, and then you can print the response, whatever response agent gives. So, and this is another way to like see the message a little bit formatted. And then this is like they've chained it here, a couple of like so the questions, and this is the answer. Then AI message is this, then human message is this, and then you can talk like this. So these are like the initial basic things just to start with. Most of the time the LLMs, the way it works is they are using the string method. You would have seen this like when you are asking the question, it usually starts giving you the answer, like you will see all the characters one after another. Like if it's typing like token, it will say TOK, and you can see on your screen like that. So because it doesn't want to wait for you have to prepare the full answer and then give you the answer like that, because you will have to wait in that case. So mostly this is used. by default they use this one. Then so this is the basics here, and then like few things that they can ask actually in the interview, that like at the most fundamental level. Like this is not, we are not going to go in much advanced or anything like that. But at the fundamental level, they can ask these kind of things, like what is basic, like what is prompting. So here we can see the prompting is like we we are loading the environment here, the keys and all. Then I'm using the same model here, Gemini 2.5 Flash. Then I'm creating the agent here. Then given message, what's the capital of the moon. So far nothing new here. Now here this kind of things is required, like sometimes they ask in the interview, like system prompt, what's the use of it. So you are restricting here, like you are giving it a role to the model, like you are a science fiction writer and you do this and that, don't do this, don't do that, on all those things you can constrain it. So here we are getting that agent here, we are giving it system prompt, and then we are asking the question, and then it will give the answer. So they ask this kind of things, like few short examples. What is a few short examples? So it's like you will give it like this. You are a science fiction writer, create a space capital, and then you will give it like a question and then answer, question and answer. And then you create the agent using this system prompt. So when you ask the question, the response will be similar to what the way you showed it before. So here you showed that what's the capital of Venus. You said to the agent, just give me this answer. So now it's giving this answer for your question. Our question is the same. What's the capital of the moon? So same way you can do the structured prompts. So it will give you the structured response. Here it was giving some error because sometimes the methods they have changed and it doesn't take it. So those kind of things I was facing the issues, and then I used this ChatGPT, and then not ChatGPT here, I used it the Antigravity here, use the agent manager, got it resolved. So you might have to do that kind of things. So it will keep telling you all these things and steps to follow and all that thing. But it can also resolve a lot of issues by itself. I was also trying to understand what's going on, so I did it this way. So then we create a class here. Basically, it's something like this. You create the class and then to the agent. But this was the errors. And here, when I was doing the debugging, it showed me all these things that you can visualize it using the graph and all that thing. So that's why I went through all these things. But so this was about the prompting. Like we see how the few shot prompting works. The next thing is about the tools. I don't want to make the video too long. We want to more practice on the interview thing. But we'll go through the code just to give some idea what it looks like. So here we have this, we are loading the environment. We can execute it like this, all this. I don't want to execute all because I want to run out of this limit thing. So the tools is like we are giving the tools, they call it usually understood as the hands, and LLM is like, it is considered as the brain, and these are the hands. It can have these tools to do the task which it doesn't know all by itself. So this is how we define the tool with like, this record address. The important thing here is the description part here, because this is what the MCP server uses when it is to find, like when the LLM has to find out like which tool it can use. It's this thing is exposed to the LLM, so that part is a little bit important for the interview. Then invoking is, you can just test invoke like this. Then to add it to the agent, we can add it like this. These are the tools, and then we define the model here. We created the agent. We say model equal to model, and we give the tools equal to square root and square. So now when we ask the agent, like, what's the square root of something, it can give the answer because it has these tools. So when we say, like, what's the square root of 144, then it will say 12. So this is one thing. Another is like, this is actually another tool, like a web search. So same as before, we are importing the keys, then we are creating the model using Google Chat, Google Generative AI. We created the agent, the message, then we are adding the web search tool. The web search tool, this is more popular to do it this way because it's a more structured output it provides. So from Tabili, import Tabili client, then we create this function. We're testing here like web search 13. Then it responds like this. Same with the agents, created the agent model tool equal to web search. Then we ask the question. Then we print like this. So we see the difference here, like in the response from the Tabili and this one. So this is web search. Another thing is the memory part. The memory is they can ask in the interview, like we are importing the keys, creating the model. So without memory, when we create the agent, model equal to model, and then we say, hello, my name is Sin and my favorite color is green, and is the response. Then we ask the question, what's my favorite color, and it will say, I don't have access to the personal information and all that thing. So basically it doesn't remember, it doesn't keep it in the memory. To keep it into memory, we have to specify it like this. When we create the agent, we say check pointer equal to in memory saver. So with this, when we create the agent, and then we say, okay, my name is Sin, my favorite color is green, and then we ask the question, and then again we ask the question next time, it remembers it based on that told me the favorite color is green. So the memory question that it can come. Then there is a multi-model messages. So as you know, right now all the LLMs are mostly, they are not only text-based. Yeah, they can work with multi-model like audio, video, and they can analyze that data as well. Same as before, we are loading the keys, creating the model, creating the agent. Nothing new here. So here to create an image, we are saying we are using this file upload accept .png. And then I uploaded one file with Apple Tower, so that's what it's showing here. And then these are the steps basically. Get a first upload file, dictionary, this is memory view. They have detailed it here, explained it nicely. And actually, if you want to learn more on this, they have a video course in which they have explained it in detail. So I'm just adding this as part of our interview preparation. So I'm showing you only this, not going into much detailed explanation, but they have explained it nicely if you are interested in more detailed explanation on this one. So here, when we ask the question like, tell me about this capital, then actually it figures it out, and and then it responds. The series files across both banks of the mighty, blah blah blah, and all that thing. Same thing for the audio input. Here we have the code for audio input, how to provide the input. We can analyze the audio as well. So the multimodal, they can ask like, are you familiar with the multimodal capabilities and how to write the code? Then you will have to visualize yourself with this a little bit. And then there is a personal shape here. As usual, loading the keys, the model, in the web search tool, then system prompt. You have a personal shape. This will give you a list of ingredients. They have left over. Then it will tell the recipe. So we're creating the agent model. Equal to model tools equal to web search. System prompt is that you are a chef. And then there is a check pointer. We are giving the memory. So here from LangChain event message, we are asking a question. I have some leftover chicken and rice. What can I make? You have some chicken and rice. Here are a few ideas for what you can make. One pot chicken and rice. One baked chicken and rice. Chicken and rice. It will be the recipe here. So this is basically at the most fundamental level. This is how you can build the agent. So yeah, now we can go and practice some questions. Okay, we forgot to talk about the MCP. So a little bit about MCP is this is the protocol developed by Anthropic. Cloudy we are familiar with. So what they have done is basically, you can think of it like backend services or app developers or database providers and all. So they would have built they generally build the MCP server, and from the developer side, when we have to communicate, we try to communicate with the MCP server using the model context protocol. So you can think of it like an specific like a JSON format using which they talk to each other. It's like English to English kind of thing. So they both understand English, then they can talk to each other. So it's like that. So when the LLM gets some request from the user, it tries to convert that into uh, that specific protocol schema format, right? In the JSON file. So it basically, think of it like it creates the JSON format. It puts that request into JSON format, particular JSON format, in which the MCP server is expecting. And then that MCP server, because it understands that language, it will then use that data provided in that format to call the REST API endpoint on the backend side, get the data, again convert that into the format which will be understood by the MCP client, like the same MCP, like JSON format. It will send it back. The LLM will again convert it into the natural language for the users, so that user can understand it. So that's how basically it works. So this is general, should have general understanding at least if they ask anything about what is an MCP. Okay, thanks.
Imagine the scene. You're sitting in a glass-walled room, or, let's be real, it's probably a Zoom waiting room with that generic blur background turned on.
Yeah, that slightly unnerving silence.
Exactly. And your palms are sweating just a little bit. You're a fresh data science graduate. For the last 4 years, you've been drowning in statistics, wrestling with valid p-values, cleaning messy CSV files until your eyes bleed, and pretty much just living inside Jupyter notebooks.
The standard academic grind, it's very rigorous, but it teaches you how to train a model, not necessarily how to build a product. There's a big gap there.
A huge gap.
Okay.
But today isn't about cleaning data or explaining the difference between, lasso and ridge regression.
Mm-hmm.
Today is the big leagues. You have secured a 1-hour technical interview with an enterprise AI solution architect. This is the final boss level.
And let me tell you, having been on the other side of that table, that architect is not looking for someone who can just write a for loop or import pandas. I mean, they just assume you can do that. That's table stakes.
Right, because the job description isn't data analyst. The job is AI engineer.
Yeah.
And it's specifically focused on building agentic workflows. We're talking about systems that think and plan and act. And the stakes are they're massive.
Mm-hmm.
Writing a script that calls an API is one thing.
Mm-hmm.
Building a system that can reason its way through a really complex problem without, burning down the company's credit card or hallucinating a non-existent product, that is a whole different ballgame.
It really is the difference between building a toy car out of Legos and, say, designing a self-driving navigation system for a busy city. The solution architect is looking for someone who understands the system. They know you can look up syntax on Stack Overflow.
Sure.
They want to know if you understand architecture, if you understand failure modes, and just the messy, chaotic reality of putting these things into production. They want to know if you can build something that survives contact with the real world.
So that's our mission today. We're going to try and condense weeks of study into a single hour of really high signal preparation. We're taking a stack of deep technical guides. We've got Ranjan Kumar's breakdown of agent internals, which is just fantastic for the theory.
It's so good. Really breaks it down to first principles.
It really does. Then we've got the production strategies from the official Langsmith and Landgraf documentation, which is straight from the source. And we have these high-level architectural concepts from Cobus Grayling.
So we are effectively trying to download the brain of a senior architect directly into your auditory cortex. We're going to give you the vocabulary and, more importantly, the mental models to just ace this interview.
And we have a secret weapon for this deep dive. I want to give a massive, massive shout out to Roshan. He provided us with the hands-on demo material that is going to anchor our entire discussion today.
That's huge.
It's incredible. Rajan actually went through the LangChain Academy training and built these specific projects, so we aren't just talking abstract theory.
Mm-hmm.
We were walking through the actual code and workflows he demonstrated.
That context is everything, so thank you, Rajan. Having those concrete examples, specifically the personal chef, the wedding planner, and the email assistant is going to make all this abstract stuff just click.
Yeah.
We're going to follow the exact progression of that training because, frankly, It mirrors how a good technical interview flows. It starts with the basics and then ramps up the complexity fast.
It really does. So we'll kick off with the foundations, building that personal chef agent in VS Code using Python and LangChain. Then we'll pop the hood and look at the architecture, the loop that makes it all run.
The technical grill
The
section.
technical grill, exactly. Then we get into advanced systems with the wedding planner. And finally, we hit the production level, the senior level thinking with the email assistant.
Ready to get hired.
Let's unpack this.
All right, section 1, the warm-up. You're in the interview. The interviewer leans back, maybe takes a sip of coffee, and asks a deceptively simple question. So, you want to build agents. What actually is an agent?
Ugh, I hate these questions. It feels like a trap. If I say it's a chatbot, I fail.
You definitely fail. A chatbot is just a conversational interface. It's stateless, it processes text in and text out. It's a glorified search engine in some ways. If you say it's just a Python script with an API call, you also fail. That's just automation.
So what's the magic answer?
The winning answer, the one that makes the architect nod and start taking notes, is that an agent is a brain paired with hands, driven by a loop.
Brain, hands, and loop. Okay, let's break that down because I feel like if you get this definition wrong, the rest of the interview just doesn't matter. You've already lost
You've
it.
lost them, exactly. So the brain is the large language model, the LLM. It provides the reasoning capabilities. It understands the user's intent. That's the part most people get. The hands are the tools. These are just functions that can interact with the outside world. Think a calculator, a Google Search API, a weather API, maybe a function to query your internal company database.
So it can actually do things.
It can do things, but the magic, and this is the key word you need to drop early and often, is the control flow.
Control flow. Okay, I'm writing that down.
In a standard script, you, the coder, decide all the steps. Step A, then step B, then step C. You write the if-else statements. If by 5, do Y. It is hard-coded. It is deterministic.
Right. It does exactly what I told it to do in the exact order I told it to do it. No surprises.
In an agent, the model decides the control flow. That's the paradigm shift. It's a loop where the model reasons, decides when to use a tool, and iterates based on a system prompt. It's probabilistic, not deterministic. It figures out the path as it walks it.
Okay, so it's dynamic. It's like giving an employee a high-level goal, go buy lunch, versus giving a robot a rigid command, walk 10 steps, turn left, extend arm, pick up sandwich.
Precisely. The employee can handle unexpected events. The sandwich shop is closed. Okay, I'll go to the taco place instead. The hard-coded robot just hits the closed door and breaks. The agent is the employee.
That makes perfect sense. And this brings us right to Rajan's first demo from the LangChain Academy materials, the personal chef.
A perfect starting point.
I loved this one because it's so relatable. Everyone has stood in front of an open fridge just wondering what on earth to cook. So in the demo, you're building an agent where you can upload a picture of your open fridge and it suggests a recipe.
Right. And for a junior role, this demonstrates a critical concept immediately: multimodality. The interviewer will almost certainly ask, how do you handle inputs that aren't just text strings?
And the answer is right there in that personal chef workflow. You aren't just feeding it a string of text. You are passing a multimodal message, an image. You're showing you can handle more than just words.
Exactly. And you need to be able to talk through the flow. The user snaps a photo, the agent receives that image. This is the observe phase of the loop we mentioned.
Got it.
But the agent doesn't just see pixels. The LLM, the brain, processes the image and identifies ingredients. It thinks, okay, I see eggs, I see spinach, I see some questionable leftovers in that Tupperware container. That identification, that's the think phase.
So it's converting raw visual data into like semantic understanding. It's labeling the things it sees.
Yes, it's creating knowledge from pixels. And then, based on that knowledge, it suggests a recipe. How about a spinach omelet? That's the act phase. It's a perfect self-contained example of the agent loop working with complex, non-textual data. It shows you know that input isn't just a text box anymore.
Now let's talk about the code itself, because that's where the interview will go.
Yeah.
In Rajan's code, he uses this abstraction from LangChain called create agent. It seems like a shortcut. Is it okay to use that in an interview context, or does that look lazy?
That's a great question. It is absolutely okay, provided you understand what it's doing under the hood. You can't just treat it as a black box.
So what is it doing?
Create agent is a factory function. It's a helper that spins up the necessary infrastructure. It wires the LLM to the tools you provide and wraps it all in the React logic. It saves you from writing a lot of boilerplate code. But the part of that code you need to obsess over, the part the interviewer really cares about, is the system prompt.
The system prompt, this is like the instruction manual for the brain, right? The agent's constitution.
I like to think of it as the job description. If you hire a human chef, you give them a job description. In the demo, you don't just say, you are an AI. You say something specific like, you are an expert weather forecaster who speaks only in puns.
Wait, the notes mention the weather forecaster with puns too. Is it just a classic example to show how you can control the persona?
It's a great example from the source material to show specificity. But let's stick to the chef for now. For the chef, you'd say, you are a Michelin star chef who focuses on healthy, quick meals using only the ingredients provided. You must output your answer in JSON format with keys for recipe name, ingredients, and steps.
Whoa, that's detailed.
It has to be. If you leave the system prompt vague, like, you're a helpful assistant, the agent just drifts. It gets creative in bad ways. It falls into what the sources call creative chaos.
Creative chaos sounds fun at a party, but absolutely terrible in a piece of production software.
Exactly. You might get a poem about eggs instead of a recipe. In an interview, you want to emphasize that you spend as much time engineering the system prompt as you do writing the Python code for the tools. You are defining the guardrails. You need to tell it what it can do, but just as importantly, what it cannot do.
So, you are a helpful assistant is a bad prompt. But you are a rigid SQL analyst who only speaks in valid JSON and never, ever guesses column names from the schema is a good, safe prompt.
Bingo! That shows you understand that the LLM is a wild horse that needs a corral. You are defining the persona, the output format, the constraints, the entire operational framework. That is what separates a script kiddie from an engineer.
Okay, so we've established the basics with the personal chef. We've defined the agent, we've handled multimodal input, and we've written a killer system prompt. I feel like I've survived the warm-up questions.
You have. You've passed the does this person know what they applied for test. But now the solution architect leans forward. They stop smiling. They want to know what is happening under the hood. They ask, when you call agent.invoke in that personal chef code, what is actually happening? Don't tell me it's magic. Walk me through the loop.
This is the technical grill. And to answer this, we absolutely have to turn to Ranjan Kumar's guide on agent building blocks. This is where we leave the high-level abstractions and really get into the mud.
This is the part of the interview where you need to be precise. You can't hand-wave here. Ranjan breaks it down beautifully into a 5-step execution loop. This is the heartbeat of the agent. You should be able to visualize this loop spinning in your head.
Okay, let's walk through it step by step. Let's use the chef again. Step 1.
Step 1 is observe. The agent wakes up, it gathers all the available context, it looks at the conversation history, maybe you already told her you're vegetarian, it looks at the user's immediate input, the picture of the fridge, and crucially, it looks at the list of tools available to it.
So it's checking its inventory. What can I actually do? Do I have a fridge scanner tool? Do I have a recipe search tool? Do I have a calculator? It's building its worldview for this one turn.
Exactly. It constructs its view of the world. Then comes step 2. Think, this is the LLM reasoning part. It often uses a pattern called REACT, which stands for reason plus act. It doesn't just jump to an answer. It internalizes a monologue to structure its thoughts.
A monologue, like a Shakespeare character doing a soliloquy.
Ideally less dramatic, but yes, that's a great analogy. The prompt engineering forces it to output a thought trace before it does anything. It looks something like this in the logs. Thought. The user has provided an image of a fridge. I need to identify the ingredients. I see eggs, spinach, and cheese. The user wants a recipe. I should use the recipe search tool to find a recipe that uses these ingredients.
So that internal monologue is generated text. It's actually writing that out to itself.
Yes. It is the model talking to itself to stabilize its reasoning. It's creating a logical chain of thought. It's mostly hidden from the end user, but if you look in LangSmith, you can see this exact text. It's the key to debugging.
Okay, so it has observed the world and it has a plan. What's step 3?
Step 3 is decide. This is where the rubber meets the road. The LLM selects a specific tool, in this case, recipe search, and very importantly, it formats the arguments for that tool.
So it has to generate something like tool.recipesearch, arguments, ingredients, eggs, spinach, cheese.
Correct. And this is an incredibly fragile step. The LLM has to generate the exact JSON structure that the tool's Python function expects. If the tool needs a list of strings, eggs, spinach, and the LLM sends a single string, eggs, and spinach, the whole thing breaks. This decision phase is where the LLM commits to a specific action.
Which leads directly to step 4, I'm guessing?
Yeah. Act. This is the only time the code leaves the brain and touches the real world. The agent executor takes the decision from step 3 and actually calls the Python function. It hits the recipe API, queries the database, or runs the calculation. This is the side effect. The agent is no longer just thinking, it is doing.
And then it gets a result back. Found recipe, spinach and cheese omelet. What happens then?
That's the final and most important step. Step 5, update state. The result comes back from the tool. The agent takes this result, stores it in its short-term memory, updates the conversation history, and acts as if the loop is restarting.
So it goes all the way back to observe.
All the way back. It observes the new state of the world. I have a recipe now. Then it thinks, do I have the final answer the user wanted? Yes, I think I do. Then it decides, I will not use a tool this time. I will respond directly to the user with the recipe, and then it acts. It sends the final response to the user's screen.
Observe, think, decide, act, update. Observe, think, decide, act, update. I'm picturing a flowchart, and it's spinning and spinning until it decides it's done.
You should be. And if you can explain that cycle clearly and with an example, you are demonstrating that you understand the mechanics, not just the magic. You're showing you're an engineer.
Now here is the killer follow-up question. I could hear the architect asking it now. My agent failed? It didn't work. Why?
Oh, debugging. My favorite. This is where you separate the juniors from the seniors. Most people just say, the prompt was bad, or the model hallucinated.
Which is probably true. It's so vague, it's useless.
Exactly. It shows you don't have a diagnostic framework. To crush this question, you are going to distinguish between an observation failure and an action failure.
Ooh, okay, break that down. That sounds technical and very impressive.
Let's start with observation failure. This means the agent started his thinking process with bad information. It didn't have the context. It observed the world incorrectly.
Give me a concrete example.
Okay, let's say the conversation history was truncated to save on tokens. So, 5 minutes ago, you told the agent, by the way, I am severely allergic to nuts. But the history buffer is only, say, 2,000 tokens long, and that message got cut off. The agent looks at the history and sees nothing about nuts.
Oh, no.
It observes a world where you have no allergies, so it happily suggests a peanut sauce recipe. It's not that the agent is stupid, it's that the agent is blind. It made a perfect decision based on flawed observations.
That's a great distinction. What's another observation failure?
A badly described tool. Let's say you have a calculator tool, but the description in the schema is just blank, where it says does stuff. The agent looks at its available tools during the observe phase and has no idea it can do math. So when you ask what's 5 plus 5, it tries to answer from its own knowledge instead of using the tool, and it might get it wrong.
Wow. So debugging starts with, did the agent even have the right information to begin with?
Precisely. Now contrast that with an action failure. This is a pure execution problem. The reasoning was perfect. The observation was perfect. The agent saw your allergy. It decided to search for nut-free recipes. It formatted the arguments correctly, but the API server for your recipe database was down, or the API returned a 500 error, or the API changed its endpoint URL last week and nobody updated the Python code.
So the brain worked perfectly, but the hands were broken.
Exactly. One is an input problem blindness. The other is an output problem execution failure. If you can explain that distinction, you show you know how to methodically diagnose these complex systems. You don't just tweak the prompt blindly and hope. You check the logs to see where in that 5-step loop it actually broke.
Speaking of fixing things, let's talk more about tools. In the outline, it mentions tool anatomy. I always thought a tool was just a Python function. Def get weather location.
Done. In a simple script, yes. In a production-grade agent, absolutely not. Ranjan's guide, and really all the best practices from LangChain, are very clear on this. A production-ready tool has 3 distinct parts. First, the implementation. That's the actual Python code that does the work. That's the easy part you just mentioned.
Okay, so what's the hard part?
The second part is the schema. This is the description, the doc string that the LLM reads. It's usually defined using something like pydantic models.
Why is that so much more important here than in regular code?
Because the LLM doesn't read your Python code line by line. It can't. It's not a compiler. It reads the JSON schema description you provide for the function. If you write a brilliant tool called SearchWeb, but the description just says searches stuff, the LLM won't have a clue when to use it versus just using its own internal training data.
So if I wanted to use Google specifically for current events, I need to spell that out.
You need a description like, use this tool to search the public internet for real-time information, current events, news, and data that occurred after your knowledge cutoff date of September 2021. Do not use this for simple math or general knowledge questions. You are effectively marketing the tool to the brain. You are advertising its purpose.
That is a brilliant way to put it. The schema is the billboard for the tool. A bad billboard means the tool never gets used.
Precisely. And the third part is the wrapper. This is your standardized error handling.
The safety net.
Right. If your tool crashes, say you try to divide by 0 in the calculator, or an API key is invalid, you don't want the whole agent to crash with a generic runtime error and kill the user's entire session. That's a terrible user experience.
So what does the wrapper do?
The wrapper catches that specific exception and returns a clean, informative string message back to the agent loop, something like error, cannot divide by 0, or error, invalid API key for weather service.
So the agent can read that error and maybe try again.
Yes. The agent sees that error message in the update state phase of the next loop. Ideally, it thinks, oops, I made a mistake. The user asked for the weather in Paris, but the tool failed. Maybe they meant Paris, France, or Paris, Texas. I should ask for clarification. Without the wrapper, the program just dies. The user gets a spinning wheel of death.
Okay, so we've defined the agent, we've dissected the loop, and we've built robust tools with schemas and wrappers. I feel like we've covered the core mechanics. Now the interviewer shifts gears. They bring up Rajan's second demo, the wedding planner.
Now we are getting into advanced architectures. The personal chef was cute. It was a single input, a single output, done. A single turn. A wedding planner is a nightmare of complexity.
It really is.
You have synchronization, real-time data from flight APIs, you have venues, guest lists, budgets. It's a multi-step, multi-dependency, long-running problem.
And this introduces the concept of context. I feel like context is one of those buzzwords that gets thrown around, but what does it mean here specifically in an interview answer?
In the source material, they talk about tool runtime and context injection. Let's make this really concrete. If I, the user, ask the agent, what's the weather like? How does it know where I am?
Oh, I assume I have to tell it. What's the weather like in New York?
A basic agent, yes. But a smart agent, a premium agent, should already know who you are. Maybe you have a user ID because you're logged into the app. In the demo, they use a getToUserLocation tool. But here's the trick. The agent doesn't ask the user, where do you live, explicitly. It checks the context.
It looks at the metadata associated with the session.
Exactly. The system sees user ID 123 is making the request. Before the agent even starts, a piece of middleware looks up in a database that user 123 is located in Florida, and it injects that information into the tool call automatically behind the scenes.
So the GetWeather tool behaves differently depending on who is asking, without me having to explicitly say it every single time.
Exactly. Without hard-coding Florida into the prompt, that is context injection. It makes the agent feel personalized and intelligent. It reduces friction for the user, which is a huge product goal.
That makes so much sense. And that leads right into the next big topic, memory. The interviewer is definitely going to ask about memory. How does the agent remember, I want a vegan cake when I told it that 3 days ago in a different chat session?
And you need to be ready with the 3 tiers of memory. This is straight from the deep dive sources, and it's a fantastic framework for an answer. Tier 1 is short-term memory.
That's just the current chat log, right? The conversation history.
Yes, it's in memory. I just looked up flight prices to Hawaii 5 minutes ago, and they were $800. It's the conversation history buffer we talked about. If you close the browser, the server session times out, poof, it's gone. It's the RAM of the agent.
Simple enough. What's tier 2?
Tier 2 is long-term memory. This is your persistent storage. This is usually a vector store for semantic information or a good old-fashioned SQL database for structured facts.
And this is where you'd store things like user preferences.
Exactly. Facts like, the user's wedding theme is rustic, the user is allergic to peanuts, the user lives in Florida. The wedding budget is capped at $50,000. This data survives across sessions. When you log back in a week later, the agent retrieves these core facts from the database to inform its planning.
Okay, that makes sense. Short term for the current conversation, long term for facts. It's tier 3. This was the one that surprised me. Episodic memory.
This is the cutting edge. This is what you bring up to really impress the interviewer. Episodic memory isn't about learning facts. It's about learning from past strategies.
Strategies, not just data points.
Right. Let's say for one user, the agent tried to find a wedding venue using a generic Google search tool, and it failed. It got way too much noise, too many irrelevant results. But then it used the specific WeddingWire API tool, and it succeeded immediately.
Okay, so it learned what worked and what didn't for that specific task.
Exactly. It stores that episode, that entire successful sequence of thought, action, observation, as an embedding in a vector store. The next time you, or even a completely different user, asks for help finding a venue, it does a similarity search on its past episodes. It recalls, hey, last time I had this goal, The Wedding Wire API worked way better than Google. I should try that first.
It remembers how it solved the problem, not just what the answer was.
Yes. It learns from its own wins and losses over time. It's actually getting smarter and more efficient without you, the developer, changing a single line of code.
That is wild. And for a complex system like a wedding planner, I can see how that's essential. Otherwise, it makes the same rookie mistakes for every new client. It just burns tokens and time, making the same wrong turns over and over.
You've got it. It's about building systems that improve.
Now, the wedding planner demo also touched on multi-agent systems. This feels like another level of complexity. Why do we need more than one agent? Can't one giant, super smart brain do it all?
You can try to use one giant brain, but it gets confused and becomes less reliable. It's the classic jack of all trades, master of none problem. The more tools you give a single agent, say 50 different tools for flights, venues, caterers, DJs, etc., the more likely it is to hallucinate or pick the wrong one for the job. The search space for the decide step becomes too large.
So you specialize.
You specialize. In the wedding planner demo, they split it up. You have a flight agent. Its system prompt is all about finding the best travel deals. Its only tools are things like Kayak API and Google Flights API. You also have a venue agent. Its prompt is about locations and capacity, and its tools are Wedding Wire API and maybe a real estate database. They are specialists.
Like a real wedding planners team. You have the travel coordinator and you have the catering manager.
Exactly. They share state, they both need to know the wedding date and the budget, but they have different prompts and different limited toolkits. This massively reduces hallucinations because the flight agent doesn't even know about cake flavors. It literally cannot get confused about buttercream versus fondant because that concept doesn't exist in its world. It keeps the problem space for each agent small and manageable.
And this is where that acronym MCP comes into the picture. I keep seeing that pop up in the advanced materials.
Yes, Model Context Protocol. In the advanced module of the training, Rajan touches on this. It's quickly becoming the industry standard for connecting these specialized models and agents to various data sources.
What does it actually do, though, in simple terms?
Think of it like USB for AI agents. Before USB, you had a different cable for your mouse, your keyboard, your printer, your scanner. It was a total mess of proprietary connectors.
Right.
MCP provides a standardized way for an agent to talk to a data source, like your wedding venue database or your Google Drive folder of contracts. If your flight agent needs to talk to a database of airline partners, MCP provides a standard interface, so you aren't writing custom brittle glue code for every single integration. It's all about interoperability.
That makes perfect sense. It standardizes the plumbing so you can focus on the agent's logic.
Exactly. If you drop the term MCP in the interview, you're signaling that you are thinking about enterprise-level problems and keeping up with the latest interoperability standards. It's a big plus.
Okay, we are moving fast. We've crushed the foundation section with the chef, and we've navigated the tricky advanced architecture with the wedding planner. Now the solution architect looks at his watch. He's nodding. He thinks you're smart. But now he wants to know the most important thing. Can I actually put this in front of a customer without getting us sued?
Section 4, production. This is the senior level. This is where you earn the big bucks.
And this aligns perfectly with Region's third and final demo, the email assistant.
The email assistant is the perfect test case because it's dangerous. It has real-world consequences.
Dangerous. How so?
Think about it. If a wedding planner agent hallucinates a venue that doesn't exist, you look it up on Google Maps and realize it's fake. It's annoying, but the damage is contained. If an email assistant hallucinates and sends an angry email to your boss calling him a pompous windbag, or replies to a major client with the wrong pricing information,
You are fired. Instantly.
a company gets sued.
Yeah.
The stakes are reputational and financial. They are very, very real.
Okay, so the interviewer asks the question directly. You're building this email bot. It reads my incoming emails and drafts replies. Do you let it just hit the send button automatically?
And you scream, no, absolutely not. The core concept here is human in the loop, or HITL. And you need to stress that this isn't just a policy. It's an architectural pattern you build into the grid from day one.
So how does it work?
This is a core feature of a framework like LangGraph, which we'll get to in a minute. But the mechanism is an interrupt or a checkpoint.
Walk me through the flow of that.
Okay. The agent executes its loop. Observe. A new email comes in from a client. Think. The client is asking for a quote. I should reply with our standard pricing. Decide. I will draft a reply offering a 10% discount because they are a returning customer. And then it pauses. It stops.
It then freezes.
It creates a checkpoint. It saves the entire state of the application, the draft, the conversation history, everything to a persistent database and stops running. Then it sends a notification to a human, maybe in a Slack channel or a dashboard. I have drafted this reply to client X. Do you want to approve, edit, or discard?
So the computer waits for the human.
Yes. The human comes in, reads the draft, maybe fixes a typo or adjusts the discount, and then clicks approve. Only then does the agent resume exactly where it left off. It loads its state from the database and finally executes the act step, which is calling the Gmail API to actually send the email.
That seems so obvious when you say it, but implementing that stateful pause in Resume is actually really tricky if you don't have the right architecture.
Which is why understanding state is so critical. You can't do this with a simple, stateless Python script effectively. If the server restarts while waiting for the human to approve, and humans are slow, they might take 3 hours to get to it. A script held in memory forgets everything. An agent built on a state machine with a persistent backend remembers, oh yeah, I was waiting for approval on the email to Bob about the Q3 budget.
The other big production concept in the email assistant demo was middleware. I usually hear middleware and I think of like web servers and request handling. What is middleware in an agent context?
It's the logic that sits between the user's request and the agent's brain. It's a layer that can modify the environment or the tools available to the agent without changing the agent's core prompt or code.
Give me a practical example.
Dynamic tools. Let's say you have a sauce product with a free tier user and a premium tier user. You don't want to build and maintain two completely separate agents. That's inefficient. You build one agent code base.
Okay, makes sense.
But the middleware layer checks the user's ID before the agent's loop ever starts. If it's a premium user, the middleware injects the powerful Goldman Sachs real-time market data tool into the context for that run. If it's a free user, that tool is simply not made available.
So the agent's core prompt is the same. You are a helpful financial assistant. But the toolkit it has to work with changes on the fly based on who's asking.
Exactly. The agent adapts dynamically based on the middleware's instructions. Another absolutely crucial middleware for production agents is summarization.
Oh, this is for handling really long conversations, right? Like a long email thread.
Yes. As an email thread or a chat gets long 50, 100 messages, you are going to run out of context window.
Right.
That's the maximum amount of text the LLM can read at once. It's a hard limit. Once you exceed it, the agent gets amnesia because the oldest messages get cut off. But the file is literally too big for its memory.
It's like trying to read the last page of a novel without knowing any of the characters.
Perfect analogy. So a summarization middleware monitors the message history length. When it gets too long, say over 6,000 tokens, it triggers a background process. It takes the oldest 20 emails, sends them to a different, cheaper LLM, and asks it to summarize them into a single paragraph, something like, summary of early conversation. User and client discussed initial pricing. They agreed on a baseline of 50K and a deadline of Q4.
And then it replaces the raw text of those 20 emails with that short summary.
You got it. So the agent retains the critical knowledge, we agreed on 50K, but frees up thousands of tokens in its context window. It's like automatic compression for conversation. And that is what a senior architect wants to hear. Not just, I can write a prompt, but I can design a system to manage the context window so the agent doesn't crash after 3 days of continuous use.
Okay, we are in the home stretch now.
Yeah.
Section 5, the interview's almost over. The architect looks at you. They're impressed, but they ask the big why question. Why are you using a framework like LangGraph? Why not just write a simple while loop in Python? It seems like over-engineering.
This is the moment you tie everything together. You talk about state machines. You say, a while loop is opaque. It's just code running top to bottom in a black box. LangGraph models the agent as an explicit graph, a series of nodes and edges.
And what's the benefit of that model? What's the winning answer for the interview?
You highlight 3 things: persistence, cycles, and control.
Okay, break them down for me.
Persistence. We just talked about this with human in the loop. LangGraph is designed to save the state or checkpoint to a database after every step, every node in the graph. If your server crashes, or if the human takes 3 days to approve that email, the agent can resume exactly where it left off. A simple Python while loop in memory cannot do that without a ton of custom error-prone code.
Okay, that's a huge win. What about cycles?
Agents are loopy by nature. They often need to retry things. The React loop is a cycle. LangGraph handles this natively. You can define explicit edges in the graph. If the tool output contains the word error, go back to the think node. If the tool output is a success, go to the final response node. It makes the flow explicit, visual, and much easier to debug than a messy while loop with a bunch of if-else statements.
Control.
Because it's a graph, you can visualize it, you can see the logic, which leads directly to the final piece of the puzzle, Langsmith. The interviewer asks, how do you know if your agent is actually working in production? How do you debug it when a customer complains?
You can't just stick variable statements everywhere in production code.
No. You say, we use a tool like Langsmith for observability. You explain that you need to see the trace for every single run. You need to visualize that graph and see exactly what inputs the LLM received at the think node, why it chose the weather tool at the decide node, and what the raw output from the act node was. If you aren't tracing, you aren't running a production system. You're just hoping.
Hope is not a strategy.
A favorite phrase of solution architects everywhere. You'll probably get a nod for that one.
Now, there's one more advanced concept from the sources that feels like a good bonus points topic to drop right at the end. Cobus Grayling's idea of deep agents.
Definitely. This is the meta layer. If you have time, you can mention this to show you're thinking about the future. Cobus describes deep agents as a kind of factory. Instead of you, the developer, building the agent line by line, you use a deep agent framework, which is inspired by tools like Claude Code to build other agents.
So it's an agent that builds agents. That feels very meta.
It's a toolkit for very long horizon tasks. It automatically attaches things like to-do lists, file system access, and sub-agent management. It's the next level of abstraction. It's moving away from, I am writing the Python code for this agent, to I am writing the high-level prompt that tells the system how to configure a new agent for this complex task. It's a great way to show you're looking at the future of the field.
Okay, the technical interview wraps up. The architect looks impressed. They shake your hand, you walk out, grab a glass of water, and 5 minutes later, you are sitting down with HR.
The vibe shift, the ultimate context switch.
Total vibe shift. They don't care about LangGraph nodes or MCP or context windows. They ask you a totally different kind of question. Tell me about your approach to building AI. How do you work on a team? How do you translate all the geeky stuff into a language that HR understands and values?
You have to reframe everything. You focus on 3 words: reliability, value, and safety.
Okay, translate for me. Give me the before and after.
Okay. Don't say, I use try-except blocks in my tool wrappers to handle exceptions. HR's eyes will glaze over. Instead, you talk about reliability. I believe in building systems that can handle errors gracefully. My approach ensures that even when external services fail, our business doesn't experience downtime and our customers don't have bad interactions.
Nice. That sounds like a mature, responsible employee. What's next?
Don't say, I use dynamic tool injection middleware to manage user permissions. Instead, you talk about value. I focus on using technology to connect our AI directly to real business data, like live inventory levels or flight prices. This ensures the answers our agents provide are accurate, timely, and actually useful to our customers, which drives business value.
And the last one, safety.
Don't say, I use LangGraph interrupts for state persistence to enable human review. Say, safety. In any system that takes action on behalf of the company, my top priority is safety. I always implement human-in-the-loop workflows to ensure that no AI sends an email or makes a purchase without proper human oversight. I see my job as protecting the company's reputation and minimizing risk.
That is the winning formula right there.
Sure.
You're not just a coder, you're a risk manager, a value creator, and a reliable engineer.
Exactly. That's who they want to hire. That's who gets the offer.
Wow. We have covered a massive amount of ground. Let's just do a quick recap before we sign off to crystallize it.
We started with the core definition, brain plus hands plus loop, driven by control flow. Then we broke down Ranjan Kumar's 5-step cycle: observe, think, decide, act, update.
We looked at Rajan's 3 brilliant demos from the LangChain Academy course: the personal chef, which taught us about multimodality; the wedding planner, which covered context; the 3 tiers of memory and multi-agent systems; and the email assistant, which was all about production readiness with human-in-the-loop and middleware.
And we wrapped with the deployment stack, using LangGraph for building stateful, controllable agents and Langsmith for the critical observability you need in production.
If you can articulate these points, you aren't just a fresh grad anymore. You are a peer to that solution architect. You're speaking their language.
You are. You aren't asking them to teach you the basics. You are showing them you are ready to build with them from day one.
Now, here's a final provocative thought to leave you with as you walk out of that interview. We touched on deep agents, these systems that build other agents.
Or factories.
If that is the direction we are heading, where the tooling becomes so good that the agent builds the agent, are we moving toward a world where Your job isn't writing the code, but managing the factory, prompting the factory.
I think that's exactly where we are going. It's the difference between being a craftsman, meticulously whittling a single wooden spoon, and being the factory manager who designs and oversees the entire production line that makes thousands of spoons.
Wow.
The interview you are prepping for today, the deep technical one we just walked through, that's for the craftsman. You absolutely need to know how to whittle. You need to know the Python, the loops, the tools. But mastering that is just the entry ticket. If you really understand the architecture, the systems thinking, the safety, the state management, you are positioning yourself to run the factory tomorrow.
That's the goal. Master the craft today so you can run the show tomorrow.
Couldn't have said it better myself.
A huge thanks again to Regin for providing the demo materials that made this entire deep dive possible. And to you, our listener. Good luck with the interview. You have the knowledge. Now go crush it.
Go get 'em. You've got this.
See you in the next deep dive.